Right, so what I want you to do is I want you to write me two equations for this. To write the two equations, your equations are going to be in the form where f of x equals either plus or minus the vertical stretch, which is your amplitude, times your function. Now, one of these are going to be a sine, the other one's going to be a cos. You have to look at the pattern for that. So you're either going to be writing sine or cosine of, then you find your horizontal compression, how the period has been changed. X, that's your variable, minus C gives you your horizontal shift, where your the X value where your function is starting, the first point, then plus D. And D, of course, is your vertical shift. So I'm going to start you off on this one. Your midline is the x-axis. So the first thing we look at is the midline on this graph tells us that the vertical shift, which is here, D, is 0. Okay? Then if we were graphing from an equation, the next thing we'd look at would be the vertical stretch, which it would give you the amplitude. So if we read from this graph what the amplitude is, you can see that you're going 2 above and you're going 2 below to get to the lows. That value is 2. So that's telling you your amplitude equals 2. So we know the amplitude equals 2. And then we would normally do start, period, and step. This value here would tell us where to start. Now we're going the other way. So we're going to look at the start we've been given, how far our graph has been shifted off the y-axis, and that will tell us what this value of C is that we're going to write in the equation. Now we've got 2 starts. So for number 1, our start is a high point at x is 0. So if x is 0, it hasn't been shifted, it hasn't been shifted left or right at all. So number 1, our horizontal shift is nothing. And it's starting on a high. The pattern is going high, middle, low, middle, high. So that start doesn't just tell us what to fill in here in our equation, it also tells us whether we've got a positive or a negative sine or cosine. What is going to start on a high like that? Type it into chat quickly. Will it be a sine, a cosine? Will it be positive or negative? Type into chat. So the one that starts at a high would be a positive cosine. If I was doing start number 2, that would be going from, well, first of all, the value of C. So for number 2, the start has been shifted to the right by this value here. Well, if this is 2 pi, this must be at 1 pi. So C is pi. And the pattern, it's going from a middle to a low, then it'll go middle, high. That would be the pattern for what? Type it into chat quickly. So to go from middle to low to middle to high, that would be a negative sine. So what do we know so far? If I was writing, I'm going to write out 2 different equations. One's going to be a positive cosine, where this value of C is going to be 0. The other one for our second equation for this green start here is going to be a negative sine, where this value of C is pi. Both of them have still got the same amplitude, so for both equations, this is going to be a 2. Both of them have got the same midline, so they're going to have the same vertical shift. And they're both the same wave, so they're both going to have the same period. They're both going to have the same value of B. But we've got to work out what that value of B is. Okay, so how do I work out this value of b here? This would change the period. Normally the period is 2 pi. From 0 to 2 pi. Oh, no, I haven't got a whole wave in there. So my value of b is going to be important. It's not just going to be 1. Let's think about when we're graphing. When we're graphing, we work out the period. We say the period equals 2 pi divided by that value of b. So if I'm going the other way and I'm trying to find b, I have to solve this equation here for b, and what would b equal? How you'd solve it, multiply, you don't want b down in the denominator, so multiply both sides by b. That would cross multiply this b up here. Then you'd divide by p. Your b, the value of b, is going to come from 2 pi divided by whatever the period is. So we've got to look at this graph and work out what the period is. The definition of the period is the length of a complete wave. So for on a cosine, it would be from this high to the next high. Imagine that wave, where would it go to the next high? That length there would be the full period of the wave. So if I knew where that point was, I could just look and see what was written under here from 0 to there. But I don't know where that is. So I can't do it that way. We've got other options though, anywhere that we can see a complete wave. So you could, if you don't mind working with negative and positive numbers, you could work out this length from this low to this low. But sometimes you won't be able to see a full wave. There's 2 other ways you can do it. Remember, if you had any pattern, like if you had high, middle, low, middle, high, that's the complete period, and we break it into 4 steps. If I know the length of any one step, I can multiply that by 4. Or how about if I knew the distance from that middle to the low? That's half of the period, and the same distance would go from the low to the high. So I can do that on this graph. I can go from this high point to that low point, and this distance there must be half of a period. So that's from 0 to 2 pi. That 2 pi is half of a period. So the whole period is going to be 4 pi. That's what our period is. Now that's not what b is, that's what the period is. To work out b, I have to do 2 pi divided by that period. So that number there has to go into this equation down there. 2 pi divided by 4 pi. So that tells me my value of b. When I want to fill in these equations, my value of b, the pi's cancel. 2 divided by 4 reduces to a half. Okay, so now we're ready to write these equations. So equation number 1, we're going to have 2 equations. For start number 1, our equation is, you've got to write, you can write f of x or you can write y equals. I'm just going to write y equals. Y equals, now for equation number 1, we said it was a positive cosine. So I don't have to write this plus. You only have to write that symbol if it's negative. Then you've got your vertical stretch, your amplitude times the function. Our amplitude was 2, yeah? That's our vertical stretch. So we're going to write 2 times the cosine of, am I recording this? Yeah, good. Keep on forgetting today. Y equals 2 times the cosine of, then we have parentheses, and we're going to put stuff inside that cosine function. Then we add on the vertical shift at the end, the plus d. Well, our d is 0. I don't have to write plus 0 at the end. Don't need to do that. Now, if there's a value for b and a value for c, you've got to have these 2 sets of parentheses there. Otherwise, that value of c doesn't give you the start. So you always have this. Your value of b goes in here, and our value of b we worked out was 1/2. Then we have x minus our shift, and that was 0. Ooh. So did I really need all those parentheses? No, I didn't need them on this one. That's doing nothing. I could have actually written there just 2 cos 1/2 of x. Yeah, I don't need those parentheses on this one, but normally you do. So let's finish that one off neatly. Okay, now let's write an equation for that second start. I'll do that in green. For start number 2, we've got an equation. You must write y equals. And for start number 2, we said we were going to be doing a negative sine wave. And our vertical stretch is 2. Where does that 2 go? Do I write 2 minus sine, or do I write minus 2 times sine? Your vertical stretch is always something you're multiplying by. It's a coefficient. The negative, it goes between the negative and the word sine. You don't have to do that dot. And then we've got 1/2, that's our b, is a half still. X minus our value of c. This is the start, how far you've shifted it, left or right. Remember this one, we had shifted it. The start here was to the right by pi. Our value of c was pi. If you're going right, you are subtracting, not adding. And then you would add on your value of d, but our value of d is 0, so we don't need to do it. Okay, so I've done that one for you. Now you take a couple of minutes and write me for this second graph over here. Write me equation for start number 2 and write me a separate equation for start number 1. Doing it the way we just did, you're going to first of all look for your midline. That's going to give you your value of d. Then you look at your amplitude. That's going to give you your value for a. Then you'll have 2 starts. And they will give you your value for c. And the pattern that you're starting on will tell you if you're plus or minus cos or sine, okay? And then the final thing you have to work out is you've got to read off the graph what the period is. And if you know what the period is, then you can work out the value of b. As you're doing this, it'd be good if you put the actual sketch of that in your notes. Look at the scale. That does not say 1 pi, 2 pi, 3 pi. It just says 1, 2, 3. Don't put pi's in there just because there's pi's in these ones. If pi isn't there, you don't get to just stick it in there for no reason. The only thing that's going to introduce pi into this one is when you do this little calculation here for b, then suddenly a pi is going to appear. So I'll give you a minute or two to work on that one, okay? Okay, so the first thing we have to do is that midline. The x-axis this time is not the midline. If it was, you'd be going up 3 and just down 1. That's not the midline. Here's the midline. Our midline is at, it's gone up 1, so our value of d will be 1. Your amplitude should be the same when you measure it going up and when you're measuring it down, from the midline down to a low point. Both these cases, don't just read this number off there. That's not your amplitude. Your amplitude is the difference between the highest point and the midline. What's the difference between 3 and 1? It's 2. You're going up 2 and you're going down 2. So our amplitude is going to be 2. Now the first start, you're starting at a low. low, middle, high, middle, low. The pattern for that first start, this is for start number 1. Your pattern is low, middle, high, middle, low. That's a negative cosine starting on the y-axis, so it's got no horizontal shift. The value of c is going to be 0, okay? For number 2, for the second start, your horizontal shift, it's gone right by 1. So c will be 1, and you're starting at a mid value, which means it's a sine. Then you have to look at the next. Is it going up from there or down from there? Middle, high, middle, low. Going from middle to a high, that means it's going to be a positive sine. So number 1 was low, middle, high, middle, low. That was a negative cosine. And number 2 is going to be a positive sine wave. Okay, let me see if I can move these things down a bit. Haven't really got room for everything I want to write there. So let's see, but I haven't worked out the period yet. The period, you could measure from this to there, from peak to peak, whoopsie, whatever that horizontal distance is, that's your period. Or if you want to, you can just go from a low to a middle. Anything that you've got a step is 1/4 of the period. That gap there is 1. Or you could do what we did last time and go from like a low point to a high point, or a high point to a low point. That's half of your period is 2. So the full period should be 4. And if you look from that high, 1, 2, 3, 4 to the other high, our period is 4. So that's not the value of b. That's not what goes in here in our equation. We have to calculate b from the period. B is 2 pi divided by the period. So it's going to be 2 pi divided by 4. This time there's nothing to cancel out that pi. You can't get rid of it. But the 2 and the 4 cancel, reduce down. We're left with pi divided by 2, half of pi. So that's our value of b. Now you just stick them in the equation. So equation number 1, remember to start with y equals. And we said this was the start of a negative cosine. Negative, and before I write cosine, I have to put the amplitude in. The amplitude was 2. Then I need the b, and the b we said was pi over 2. Then we have x minus c. Well, this one starts on the y-axis, so it hasn't been shifted horizontally at all. So I don't actually need to put more parentheses with x minus c. I can just put x in it. Then I have to add on the vertical shift, and this one did have a vertical shift. Remember, it was up 1. So I put plus 1. And for start number 2, we're going to have y equals, start number 2 is the beginning of a positive sine wave, So I don't need to write the plus, but it has been stretched by 2. That has been written first. 2 times the sine of b, which is pi over 2. And this time there is a horizontal shift, so I have to have that factored out. X minus, and we're subtracting because we are moving right. We're moving right by 1. Close both sets of parentheses, then put on your midline value at the end, up 1. Okay. So for the rest of the lesson now, what we're going to be doing is we're looking at graphing 2 of the reciprocal trig functions. We're looking at graphing secant and cosecant. We're going to do tangent and its reciprocal tomorrow. So before we get anywhere with this, what does the word reciprocal mean? Yeah? If I wanted to know graph a secant of theta, it's the reciprocal of something. Reciprocal means 1 over. Secant is the reciprocal of cosine. 1 over cosine. And when we want to graph a cosecant, cosecant is the reciprocal of sine. Reciprocal just means 1 over. So if I wanted to find the reciprocal of 1, the reciprocal of 1 is 1 over 1, which just equals 1. We're going to have to plot some of these points. That's why I'm talking about them. What's the reciprocal of negative 1? 1 divided by negative 1 equals negative 1. And for all of you, okay, type in now into chat. What is the reciprocal of 0? What is 1 over 0? The reciprocal of 0, remember you can't divide by 0. Dividing by 0 is undefined. Right, if you've got some graph paper now, try and very neatly, using graph paper if you have it, draft one period of a sine wave, okay? So we were graphing a parent sine wave because we're going to graph a cosecant, but a cosecant is 1 over sine. So we're going to look at a sine wave first. So remember the parent function, y equals the sine of x. The pattern goes middle, high, middle, low, middle. The midline is just along the x-axis. It has an amplitude of 1, so your high points are at 1 and your low points are at -1. And we draw in and normally draw in a little construction line there, yeah? A high and a low line. And then when we're graphing sine of x, the period of the parent function, the period is 2 pi. And we break that into 4 steps to jump between points. And 1/4 of 2 pi is, so our step is 1/4 of that. That's pi over 2. So graphing in your sine, we start with a midpoint here. We take a step, which is 1/2 pi. Now I've deliberately divided pi into 4 squares, so I can do pi by 4. This is 2 pi by 4, which is pi by 2. So that's 1 step. On mine, I'm going over 2 squares. That would take me to the high. Oopsie. Take a step, go to the middle. Take a step, go to the low. Take a step, go to the middle, then graph it in. Then coming backwards, you'd go low, step there, step here, and pull that in. So that is a graph of the parent function y equals sine of x. Let's fill in this table and see if we can use this table then to give us our values for the cosecant of x. Some people actually use these waves. They don't use the triangles that we do to actually work out, to evaluate like sine of something. So if they wanted to find the sine of pi, they just look for pi on the graph and say, okay, what's the value of my function here? When x is pi, the y is at 0. So the sine of pi is 0. When x is pi over 2, the sine is up here, it's at 1. When the angle is 0, you're at the point 0, 0. When x is 0, y is 0. Yeah, you can do that. At 3 pi by 2, that's this angle here, use the graph. The sine of 3 pi by 2 is this value here, -1. When sine is 2 pi, you're back on the x-axis again, so your y has a value of 0. Now for pi by 4, these points in between all of those, this value here, I don't know if you'll remember, but the sine of pi by 4 is actually 1 over root 2. When we do our 45, 45, 90 triangle, that's your y divided by your r, it's 1 over root 2. And we tend to write that as root 2 over 2, which has a value of about 0.7. You're going up about 0.7 there. And if you go to 3 pi over 2, which is here, you can see it's that same y value. This is also going to be the square root of 2 over 2, about 0.7. When we get to 5 pi over 4, you're here, and can you see you're going down by that same amount? This is negative root 2 over 2, and so it is as well for 7 pi over 4. Now we're going to do the cosecant. So I'll do this in red. Right. So if I want to graph the cosecant of x, the cosecant is the reciprocal of the sine. So if I look for any angle, like when the angle is 0, the cosecant is going to be 1 over this sine. 1 over 0, which is undefined. On a graph, what undefined looks like is a vertical asymptote. So where x is 0, put in a vertical asymptote. And when you put a vertical asymptote, you must always label it. I want to see x equals 0 for every asymptote. Then our next value at pi by 4, so that's this, for this tick mark here, the sine was 1 over root 2, so the cosecant is the reciprocal of that. It turned upside down, and you end up with the square root of 2, and we're going to have to graph that, so look over here, I've written it out for you. The square root of 2 is about 1.414. So on your graph, go across to pi over 4 and go up about 1.4, about there, and have a point there. Then for the angle pi over 2, my next grid line on my graph, the sine is 1, so the cosecant is 1 over 1, which is 1. So the two graphs are going to intersect on that high point there. At 3 pi over 4, it's going to be the reciprocal of this. It's going to be the same as that. It's going to be the square root of 2, which we know is about 1.4. So graph that one. Then we're at pi. The sine is 0. So the cosecant is the reciprocal of that, which is undefined. And remember, that turned into a vertical asymptote. So I have to draw a vertical asymptote in here. And when you draw a vertical asymptote, you've got to label it with x equals pi. Then this one was negative. So it's going to be that same value that as we've got up here, but negative. The cosecant is going to be negative the square root of 2, which is about negative 1.4. It's going to be down there. At 3 pi over 2, this was negative 1, and 1 divided by negative 1, the reciprocal will be negative 1. So those graphs are going to intersect at that point there. This one again is going to be negative root 2, so again about negative 1.4. And the last point, when my angle is 2 pi, my sine is 0, so my cosecant, which is the reciprocal of it, will be undefined, which will be a vertical asymptote. Label it with its x value, that's x is 2 pi. Now that's one cycle going forwards. It started here, so my cosecant is not going to, if I'm looking at the pattern for cosecant, it's not going to start with a mid, it's going to start with an asymptote. But then it had the same high point, then it had an asymptote. Notice all the middle points are turning into asymptotes. They had the same low value, but then this final one that was a mid on the sine turns into an asymptote on the cosecant. So that's your pattern for a cosecant. It goes asymptote high, asymptote low, asymptote. Now we actually have to put the graph in though. This is a high. How do you feel on the high points of your day? Are you all happy and smiley? Think about how those points would look like if you joined them up. Does that look like a giant happy smile? So put a big smile going up to infinity on the highs. And here's a low. How are you feeling on the low parts of your day? You're feeling sad. Do a frown or a sad face on the lows. And that's literally how you draw a cosecant. You graph a sine wherever it's got a mid value. So let's go backwards. Here's a mid value. Here's a mid value. Put an asymptote through the mid values. Label them. X equals negative pi for this one, and here was this other mid value. Then look for all your high points. They intersect there. Smile on the high. Now it's got to go exactly through that point and then up again. That's the only place where the sine and the cosecant intersect. Look for your low and put a sad face, a frown on. Ooh, see, I've graphed that wrong. I went above the low there. That's me trying to draw with this funny mouse. That's, oh no, I can pick it up and move it. Yes, there you go. Okay, so that's how you graph a cosecant. If you want that in notes, here are some notes for you. Graphing cosecant, first of all, just rewrite your equation and replace the word sine with replace the word cosecant with sine. Now, that's just going to give you a construction line. You're going to graph the sine of x, but just as a dashed line, really lightly or in a very low light color. And that's going to give you all the construction that will help you draw your actual cosecant. Your cosecant, every time there's an m, you replace it with an asymptote. Every time there's an m, you replace that with an asymptote. You'll draw, you'll draw a vertical asymptote through every m, and then you'll smile on the highs and frown on the lows. That's literally what you do. Drawing the cosecant with smiles and frowns, you smile on the highs and frown on the lows. If you want a pattern, the pattern goes A, H, A, L, A, asymptote high, asymptote low, asymptote, but you can just use the pattern for a sine and just know you replace the M's with A's. Now, what part of what we just graphed was the cosecant itself? If you graphed it on a calculator, this is all you'll get. The cosecant is just these smiles and frowns, but when you are graphing it, and what we're going to look for on your graph is you must put in those asymptotes. You would have an asymptote here, and you graph those first. Those get graphed before the smiles and frowns. Yeah? And when you put in an asymptote, you must also label them where they are. Okay, that's literally how I grade your work. I'm looking for those. Did you get the period right? I'll know if you've got the right labels on your asymptotes. Okay, and then these are your high points. So you've probably dashed in your high line and dashed in your low line. Yeah. How do you think you graph? That's how to graph a cosecant. If you had to graph a secant, you do exactly the same thing, but secant is the reciprocal of cosine. So you just basically graph a cosine as a construction line and turn it into a secant by putting asymptotes. You'll put an asymptote through every midline value. Every midline value will turn into an asymptote. So if you're graphing a cosine, which goes high, middle, low, middle, high, you'll literally put asymptotes through the midlines. And you'll put that will get half a smile, that will get a full frown, that will get half of a smile. That's one period of a secant, okay? Let's practice some of these. How long have we got? Good, I want to go through one nicely that you practice on your own. And you've got a load of these to do for homework. So let's graph this one then. How you're going to start is you're going to lightly, just very lightly, because it's not your real graph, you're lightly going to graph y equals 2 times cosecant, replace it with sine. So how would you graph that? The first thing you would graph would be the vertical shift, which is this. That's your midline. That would be at 1. Then you graph, so we've done that. Do that first. The next thing we graph is we graph the amplitude. We go up to, which would take that up to 3. And we go down to, which would take us to -1. Okay. Then we look at the start. The start is how far you've shifted it. This would shift, if you're adding, it's actually going to shift it left. We're going to go left by π/2. That's a horizontal shift. So our start is actually going to be at x is negative π/2. You do the opposite of what it says on the inside, yeah? So, and we're graphing a sine, so the pattern normally goes middle, high, middle, low, middle. So we're going to start at x is negative π/2 on the midline. On my graph, that's there. Circle your start point, always circle your start. Then we're going to take a step. Don't know how big the step is. So let's look at the period. The period, has it been compressed? No. Our value of b is 1. There's a 1 in there. We're multiplying by 1. So your period, remember, is always 2π divided by b. So it's 2π divided by 1, which is just 2π, but that's not what we graph. We graph the step. We get that and we cut that into 4 pieces, 4 steps. So each step is going to be π/2. So from this midpoint, I take a step that's the size π/2 and I get the high. π/2 would take me to the axis there. Each step on mine, the way I've planned it, each step is going to be 2 squares. Take a step and I need to be on the high. Take another step, be at the mid. Take another step, be at the low. Take another step, be at the mid. So that's 1 period, and you could dash that in if you wanted to. But remember, that was graphing sine. What we really wanted to graph was cosecant. That was 1 period going forwards. Let's do as much as we can going backwards. From a high middle, this will be a low. Take a step, we'll be at the midline. Take a step, we'd be at the high line. So that's my sine wave, which isn't what I really wanted. What I'm supposed to be graphing is the cosecant. So how do I turn this into a cosecant? That thing to disappear, go away. Remember, through every mid value, put an asymptote. So identify them all. There's one there, there's one there. That's our start one. That's our really important one. Put an asymptote through every time the sine crossed its midline. Here and here. Label them all. This is at -3/2. Ooh, and those are x values. X equals, this is x equals negative π/2. This one is x equals positive π/2. And this one is x equals 3π/2. Okay. So see if you can turn that one into cosecant for me. Identify the highs. You can put a whole smile on this high here. Now those have to go up forever to infinity. This one I can only get half a smile on that one. And I didn't draw any more of that graph, but can you see that would go up to a high there? There'd be another half a smile there. Then look for your lows. And just graph a frown. Ooh, I keep on going too high on those. Can you hang with me for 1 minute? What I quickly want to discuss here is the range. It's only going to take a minute. What's the range of this function? What are these lowest values? The function is just the red bits. It's going down to negative infinity. Oh, negative infinity, not negative pi. Trying to hurry now. Negative infinity. Then this red bit goes up to -1 there, and then comes down. So it goes to -1. It's included. That point was included on the graph. Then there's a great big gap with none of the red graph there. There's a big gap, and the graph starts again. The lowest point on this smile is at y is 3. So you have a gap from 3, and then up from there it goes up forever, up to infinity. Okay, we'll do more of this on Friday, and we'll be graphing tangent and cotangent tomorrow. Sorry, I held you back for a minute. You may go now. I hope that made sense. If you have any questions, hang on in the meeting and I can answer them for a second, okay? Bye, guys.